Welcome back, everyone. It's great to be here with you for another panel with representatives of the transatlantic defense industry. The last panel looked at the industrial ramp-up, the current situation. This panel, we're gonna pick up from the end of the last one and look ahead to the near future, not the distant future, but application of lessons, of technology, and what we should be looking for over the near horizon. And we have a really interesting group of executives here with some somewhat different perspectives. Maybe let's just start from the battlefield in Ukraine. I think the world has been stunned by the role technology has played. This, as we heard, we've heard several times today, this mix of old and new, sort of mix of World War I and World War III, perhaps. Hopefully not World War III, but from your perspectives, what are the lessons that are being learned from Ukraine, and how is it being applied in your business? And maybe, Safra, I'll start with you. And as I was just saying in the back, I among other people, hadn't quite realized the role Oracle is your business in defense. So how do you see?
Well, for us, we understood one thing. When the Russians invaded Ukraine, we understood that speed and data were going to make the big difference in the response. And one of the things we made available for the government at the time, but is a lesson that can be learned much more broadly, is that our enemies are collaborating in their technologies, and one of the most straightforward ways we can all collaborate is share our data when we can very, very quickly. And one of the things, the ways to do that is to make sure that it's available and not siloed in separate systems. And I think that of all the lessons, those using the newest technologies quickly is probably one of the most critical pieces of learning.
Linden?
Sorry, I'm going to share. Right. Oh, I missed some. Sorry.
That's okay.
Thank you. Yep. So, I think what we have observed, perhaps most of all, is that in Ukraine, what the conflict has shown in a growing way over the past 2 years is that, yes, there is contested airspace, but even more important, and this is something new for the world, really, is that there's extremely contested spectrum. The electromagnetic spectrum is contested from the low bands to the high bands, from air defense radars to jammers that are shutting down GPS, that are shutting down data links, that are messing with radios. All of that is new for the defense world. And I think that we've never had to face that before, certainly as the alliance. And we're going to have to learn how to face that now and get really, really good at it and get better at it than the adversaries are now. And the second point is that the contested airspace is characterized by the fact that the Soviet air defense systems, which were invented probably more like in the 50s and 60s, have been effective to date in Ukraine, kind of on both sides, at preventing anybody from getting air superiority, even periodic air superiority. Until you figure out a way to suppress and mitigate that pretty much ancient air defense system, we also, as an alliance, have a serious problem. So those are the two things that pop out at us as a company that exclusively builds unmanned aircraft systems.
Ahmet?
Well, first of all, during the 17th century, defense industry led the innovation, but especially at last 2 decades, we see commercial technologies like drones, the communication, and some space technologies causing some problems against conventional weapons. What we see in the Ukraine war, for example, eliminated tanks by drones is higher than eliminated tanks by missiles. This is new for battlefield. We all invest on the conventional technologies. So commercial technology make differences in Ukraine war. And the second issue in drone case also, we were investing more against cruise air defense domain. In the air defense domain, we were investing for cruise or helicopter or aircraft protection to our borders. But now there is a new problem. There is a swarm drones, very cost effective, very common. So you need to develop new methods like smart ammunition-based air defense, HPMs and lasers. So the second impressive change is coming from air defense doctrine. And also maybe we can say, for example, Starlink is another impressive development, because in the past there is no such kind of communication systems. Now it is very difficult to stop this kind of communication by using the jammers and electronic warfare. So I can say three main issues: drones, air defense, and the communication for Ukraine war.
So maybe taking this a little further, the digitization of the battlefield. I mean, the US for 20 plus years has talked about network-centric warfare, and we've had these efforts, but Ukraine has just supercharged all of this. You know, how do we make it work, especially in the face of things like electronic warfare and other types of problems that arise with the digital communications and digital infrastructure that we encounter in civilian life?
Yeah, I think you have to really step back and look at the picture of not only our current threats, but our future threats. And sort of, that saying in hockey, skate to where the puck's gonna be. And to do that correctly, you have to understand who you're dealing with. Because as much as it's the Russians, it's also the Chinese, the Iranians, the collaboration behind all of them. And each one of them, the countries are really known, especially China, for extreme tightness of their military, their universities, and their commercial enterprises. So this extreme collaboration is not really found in free countries. Every government, military does what they want, but every company does what they want. And the university's the same. So if we want to be able to deal with the next crisis, as well as this crisis, we have to understand that that requires extreme collaboration. I said it on one of our, on the lunch earlier. One of the things we realized a while back, really through our commercial business, is that we actually had to make sure that our cloud worked with Microsoft's cloud and with Google's cloud. And these are two companies we are known to compete with quite viciously. However, we had to focus on the mission. And in addition, I think, obviously NATO is a collaboration, but we've got to bring it to the next level where there is data sharing and there's an underlying infrastructure so that so much of the data that's coming off of many of the things you all make is available to be shared, because we are going to be in shared, contested spaces, and we need to make sure that us bringing all those assets together is an advantage and not a disadvantage. And of course, in the time of AI, this is even more so. I'll wait, because we'll probably talk a little bit about that in a minute. But of course, AI is only as good as the underlying data it learns from. And that's our next step.
Linden?
Okay, I would add to that in electronic warfare, I think we in the States and in the West in general are pretty good at solving problems that are thrown at us. What is new here is that these problems are changing weekly, maybe sometimes even daily. So the feedback loop of now the adversary has changed their approach, we have to adapt to it, is on a scale that we're not used to. To field an improvement, to even a software improvement, is not, that time scale is not relevant any longer. To change contracting for a commercial service, which is part of some of these data links, is also, that time scale is not tactically relevant anymore. So anyways, that feedback loop has to be really quick. We've got to change our whole mindset in that sense. And I'd say again, on the electronic warfare side, traditionally, like Cold War kind of thinking, you collect your data for waveforms and for radar waveforms and communications waveforms with strategic assets. It's a strategic thing. The tactical guys have their sensors, but the two are stovepipe. They're not connected, and there's no way to get the tactical data and the strategic data together to provide a real-time common operating picture. That is another challenge. It's not easy. It's easily said, but that's something that's you asked how to address this problem. That's part of the solution.
And in this regard, data becomes very crucial in this battlefield, and you need to deploy wideband communication to the battlefield, but without any base stations and any commercial services. So it is very difficult. It is not easy to provide this kind of wideband communication to all battlefield. It needs very huge amount of investment, and also it's not easy to protect your communication bands against electronic warfare and cyber attacks. So to use these advantages, to do these data advantages, you need to deploy this wideband communication to all area to protect your data against cyber attacks and electronic warfare attacks, and to implement those data to AI systems to make difference in the battlefield. So yes, we are accustomed to use very advanced communication systems in our life, but when it comes to real battlefield, it is not easy to deploy it to the battlefield without any commercial help, and it is not easy to protect your data against cyber attacks. So if we succeed this by the NATO allies, it can make difference by the leverage of these data and AI systems.
Safra, you mentioned the hot topic,
Yes.
AI. Maybe this time I'll start with Ahmet. We'll go in the other direction. But we've seen indications from the battlefield in Ukraine of AI starting to be used in targeting and some other areas. I'm curious how all of you see AI getting more integrated into defense systems, in the very short term, this year, but over the next, say, 5 years, and especially given the pace of change. I mean, I think everybody has been amazed at the pace of evolution of large language models and their impact. So how do you see it? And also, please look at some of the ethical issues that you face with AI. So, Ahmet.
This is very hot topic, AI. And we consider, I am the representative of Aselsan, we consider AI as a horizontal technology for all products and processes of Aselsan. We have prepared our AI implementation program and started to execution. And the name of the program is Aselsan Next also. First of all, we have started digital transformation project inside the company a while ago, and project is aiming to combine all the data within Aselsan and build a digital platform using AI to make quick, reliable, and efficient decisions, and to use these AI systems in all inside processes. And the second pillar of this program includes using these AI features for all Aselsan products like radars, cameras, sonar systems, electronic warfare communication, and now it is compulsory inside our company to consider AI features for all products if it is necessary or not. And the last but not least is to use these AI systems in business development and the integrated logistics and customer success issues. So it is very game-changing if we implement on time these AI systems to our products and processes. And one of the issue what we are working on is to make some combinations with some startups to large-scale companies like Aselsan to foster this development. And we have, as of today, we have some spin-offs and spin-outs inside the Aselsan to make these developments faster than before. This is the idea. So if we achieve these goals, AI will be the game changer in defense industry also.
Linden?
Yeah, AI, I think some specific applications today for us, there's some mundane things like for example, writing tech orders or manuals as operating manuals, which more people would say maybe, is extremely laborious and takes hours and hours and hours of humans looking through data. And so it turns out large language models can do that, at least a lot of that, really well. And that's sort of mundane, but it's quite important because that's a big part of our business. And I'd say also that ISR data that is extremely data intensive, like signals intelligence, or things like maybe some kind of radar data, and other kinds of sensor data. Applying AI to that to draw conclusions is something that we are already doing now, although not on a fielded basis, but it's something that is coming, and I think it will be fielded in the coming. That's a near-term thing. A longer-term thing is that those conclusions that the AI achieves with the sensor data are used for command and control of an asset. That will come to, but that will take a little bit longer because having an asset, in our case, flying around that's making decisions on an AI basis is still a bit of a taboo issue. But certainly the big opportunity in the near term is using AI on this very, very, very calculation-intensive sensor data that improves our ISR picture.
Safra?
Yeah, so the whole topic of AI is one of those things that right now, just with like every new technology, whether it was GPS or other, at first it was a thing in itself, and then it became in everything. From, just like you said, writing a manual to finding an adversary in a very complicated field. Like, it's going to be literally in everything. In our cloud, for example, it is not humans that protect the security of the cloud. It's AI that protects it. We jokingly say our robots fight their robots because no humans could fight that way. And the reality, though, is, again, you cannot have it until you have the correct platform that can handle all the data, but since it is military data or intelligence data, it needs to be able to be both educated, but yet not run free. You can't just ask it in ChatGPT and secure it that way. It's got to be specific for the use by you all for its purpose. And ultimately, we should spend a lot of focus on figuring out how to make sure that data is in fact available for all the uses we just discussed, because our adversaries are not only good at this, they have almost unlimited resources that they deploy on this. So everything taken from the public, everything done in the open, is then focused on with enormous resources on it. So this is not, even as we worry about some of the ethical rules and all those issues, we need to understand that our adversaries are ignoring those completely. And it's on us to make sure that we are both following our principles and winning. Because really, it's freedom of the free world is really at stake here.
I'd love to tie all this back to the theme of the day and the reason we're here, the Defense Industrial Pledge. Safra, you talked about how you compete with Google and Microsoft in the cloud. We've heard a lot about, and one of the elements of the Defense Industrial Pledge is standardization and integration, interoperability. Now, NATO and defense companies in NATO have struggled to standardize something as basic and as physical as 155 artillery shells. How are we going to do it in the digital world? I mean, digital secure communications is already a problem for NATO, and things are only going to get more complicated.
Well, if I'm going to answer first, I'll tell you, we made a conscious decision with Microsoft and with Google that we needed to be interoperable so that a customer could, let's say, use our database in our cloud and use one of Google's products or one of Microsoft's products and use them seamlessly without charges for moving data, but also technically integrated. And our decision was it was more important to meet our customers' needs and that we could compete in other ways than that we should be locking them in. And I think that in some ways, I mean, I heard about the shell. I mean, I can't comment on their businesses, but for us, there's just so much momentum for moving to digital that we should not be the ones putting up walls and making it harder for our customers.
Linden?
Yeah, for standardization, our philosophy has been that, okay, we do build airplanes, and airplanes have to be safe, and so you have this airworthiness issue with the actual platform. And every time you change anything on the platform, it's a big problem because you got to make sure it's safe. However, the mission system, which is the real reason why you have the airplane in the first place, that should be plug and play, which is easier said than done, much, much easier said than done, because we've been talking about this for 15 years. But our philosophy is that that's where we have to be. So open mission system standard, which took a long time to finally achieve, I think is now pretty widely used. So we can provide a vendor, a payload vendor with an interface, and it's up to them to meet that interface document, and if they do, then we can at least plug in the payload. We've also, this is independent of any government standard, we've developed software development kits that allow a payload vendor to also adapt his software to our interface so that we're not doing a month or years long integration. He's complying with the interface, and as long as he does that, then integration on the platform is way quicker and therefore cheaper. Universal arms interface is a new thing that is going to allow weapons that meet the interface to be very easily integrated, very quickly integrated. And you've all heard of the movements towards autonomy, which this is more of a developmental issue at the moment still, but the focus is that autonomy software will be modular, and that it won't be confined to having only the OEM or only one provider be in charge of it, so that even small companies that are very good at a certain part of autonomy can plug in their modules seamlessly. So I think those are some initiatives that are we're taking very seriously to help the standardization problem that you mentioned.
Ahmet, you get the last word on this.
I am one of the board member of NATO STO. My observation at that meetings is we always focus on financial contribution of nations, but we need some technical contributions. There are many STANAC groups and there are many technical groups. So sometimes my observation at that meetings, the contribution is not enough from some allies. It can be a solution, and we understand that at a crisis, at a conflict, we need to use our stocks and the systems all together for one NATO ally. So we need to increase our joint programs also. If we increase joint programs, it can help the integration phase by the starting point of the design and development, and it may help the maybe integration of the all allies systems all together.
I want to thank the panelists. This is a fascinating look into the future where we're all going to be watching what you do. We probably won't see it, and we probably won't understand it either, but I know it's going to be critical. So thank you very much. Thanks.